If you want to, you can record your own copy as well. I am completely fine with people recording my conversations. Just don't share them too much because I do tend to swear in these things, and I'd rather that not get out too much. Please and thank you. So we are recording. So, as I said before, you should have your VM up and running and ready to go. Once you have your VM up and running, you can select the RDP information so that allows you to connect to your virtual machine. Once you are into your malware virtual machine, and that's what I'm going to call this host environment. Even though it's a virtual environment in Azure, we're going to consider it our host environment. This is our malware VM. Inside of this, we're going to do all of our work. I would like you to be able to start Kali at this time, please. We will be starting up both Kali and Remnux today. You should also be able to take a look at the sample software that I have in Learn. If you take a look, I made a new module available in Learn, walking us through the process of creating malware in Kali. This is one of two ways that I hope to take a look at this semester for creating malware. This is something we have seen before. We have used this tool, if I'm not mistaken, we used this tool in pen testing to create a payload as well that we were able to use to get a remote shell. I'm pretty sure I did that with you guys because a while ago I realized the power of the MSF Venom utility, and I wanted to show you the overlapping skills that these technical courses can give you. The tool we're going to use, MSF Venom, is the same tool that we used to create a remote shell in our pen testing classes last semester. All right. I've given us 2 hours to get this work done. Should be enough time to do what we need to do. Wow, was that slow? Has anybody successfully launched Kali? You and me, Himanshu. Okay. Once you have Kali up and running, please open up a terminal window if you don't already have a terminal window open. Before we do anything in Kali, we're going to want to ensure that we have a folder for our work. And I know I mentioned this last time when we were doing pen testing, and I know I tried reinforcing it a couple of times when we were doing pen testing, but it is even more important now. Just not because of the workload we're doing or the workflow, but the mindset of security. Pen testing was important enough to have your work organized. When you're dealing with viruses and the very unpredictable nature of some of the things that we're going to be working with, organizing your work, organizing your files, making sure things are delineated becomes all the more important for our workflow. Okay? So the first thing I want you to do, once you are logged into Kali, and you should see that you need to log in as a user ID and password that you created when you set up Kali before. Once you're logged in, you don't need to become root for this. You should be able to do it just as the account you've created. Once you're logged in, create a directory, and you can call that directory add user, because really that's the malware that we are creating today, is the add user malware. Hopefully Himanshu and I will get there. Doesn't look promising. Yeah. I think our gerbils have fallen asleep at the wheel. Oh, for the love of all things holy and just. Himanshu, as I said, I am recording this. We will get here, and frankly, you're going to need your environment set up. That's not good. All right, so just for the purposes of expedition, I'm going to move on and show you what I want you to do for those of you that are connected. And frankly, what I want you to do is very straightforward. As I mentioned, it's all in that PowerPoint set of stack of slides that I have made available to you in the lecture notes for this module. We are going to start up Kali and Remnux. The reason is because we're going to use Kali to generate a bit of malware, and then we're going to use Remnux to run an analysis. So you're going to really need to start both VMs. I can't even start one, so we're going to have to fix this. But that's not your worry. All right. Once you have that, you need to create a directory. I said call it malware. You can call it whatever you want. The virus we are creating is based on an add user payload available inside of MSF Venom. We're going to use the MSF Venom utility to create this virus. It's the reason why when we set up the VM that we have here in Azure Labs, the reason why I was able to set up the very basic Kali VM, the only uses the top 10 tools, because the MSF console is probably number 1 or 2 in their list of top 10 tools. And because we installed MSF console, we gained access to one of the utilities that supports it, MSF Venom. We're going to use this to generate viruses. And we have, as I said, we've seen this in the past. We've used it to create some payloads for our pen testing activities. It tends to be a little bit more unwielding when it comes to creating payloads, specifically remote shells. And that's what we used it for, to generate a remote shell. And then we modified it so that we could deploy it into our target environment. It was more difficult. We found other ways of using shells. However, MSF Venom itself is very good at creating these kinds of payloads. And we're going to use that for creating a payload. The payload we're going to look at is the add user payload. All right. And these are the commands right here. All right. Oh, there it is. So I'm just going to use Notepad as a bit of a whiteboard. First off, this entire line is one complete single command. All right, it is not two separate lines, it is one huge line, as you've seen in the past. And I want to talk about, I mean, you can start looking at it and typing it in and see what it looks like. We're using the MSF Venom command. The -p is the payload. We're going to do the add user payload for Windows. With the add user payload, we're going to specify a couple of parameters. The username is malware lab user. You can have any username you want, and the password is going to be user@123. Only because when we create this user, we don't want it to throw any errors because the password doesn't meet the password requirements of the target environment. If you'd use something simple like password, you might not be able to detonate this payload. And I'm going to ask you to detonate this payload. Not right now, but in the future. All right? I can't remember what WMIC is, but it's some kind of a security feature or something like that. And then the file format, the -f, executable. And once we do that, it'll just generate an executable for us. We redirect the results to a file that we're going to call malware adduser.exe. And I'm sorry, I can't remember what the -WMIC equals true argument is. I used to know what it is, but I can't remember it off the top of my head. Okay, so that's the injection I want you to type in Windows. It's a correction, not in Windows. I want you to type that in your instance of Kali. Imanshu, is yours working? This looks like mine is working, except I messed it up. Okay. All right. Well, like I said, I'm recording this anyway. But again, here's the command. But as I mentioned, the command is available to you as content in Learn. Okay. So first case, make directory add user or malware or whatever. I don't frankly really care. I want it so that you can organize your work. That's the deliverable for this. Okay, I'm going to call my directory add user. cd add user. Empty folder, perfect. MSF Venom, tab will work. -p for the payload, Windows /add user. User is equal to malware. You can use any ID you want, but if you're going to follow my notes, _user, pass, and we do want to have a complex password, so we have a combination of uppercase, lowercase, numbers, and special characters. And that's what I have. Uppercase, lowercase, special characters, and numbers in that order. So providing that's not blocked in our target machine, it should be good. I'm going to look into that while you're working on this. -f for the format is executable, and we're going to redirect the results to malware _adduser.exe, just like that. It does take a while for this to run, and then all of a sudden you will get your prompt back, and you can do an ls, and you will see that the adduser.exe file is there. Now, obviously, we are in a Linux environment. Obviously, our executable isn't going to work. It gives us a little bit of a warning, but when we take a look, it's created a 74 kilobytes executable file that we should be able to deploy into a different environment and actually test. When we set up our Windows environment, that's one of the things we are going to do. Okay? Was everybody able to create the add user executable? Okay, we'll let it process. I'm going to try a different Kali and see if that works. I doubt it, but here's hoping. Okay. Once you have that done, you're going to find a number of other executables to create as well. There's two more on slide 4, and then there's one at the top of slide 5. Please do not look at UPX commands just yet. Still nothing, eh, Manchu? Man, you've got the best gifts, however you want to say it. You've got the best, man. Your animated image game is on point. Well done, sir. Okay, so it bounced again, I'm guessing. I apologize. I'm going to come up with a better system for next week. I'm done fighting with this. I thought we were having better performance. Clearly, we're not. I'm working with the college's information security group. They've come up with a better system. We'll try and implement it next week. Okay? At the end of the day, however, I want you to type in the following commands, where we will use the shell bind payload. Shell bind on a different port. You may want to give it a different name so you can have multiple, oh, you do right here, shell bind another port, just to see some of these options for creating different payloads, okay? And then we'll take a look at the UPX commands later on. UPX is a standard way of packing executables, making them more difficult to analyze. Hold off on that. We'll come back to that in about 5 minutes. Just type in these commands, these other two MSF Venom that you've already typed in, these other two on slide 4, and then the fourth one at the top of slide 5. Please go ahead and do so now. I guess I have not muted my mic, so I inadvertently overwrote one of my malwares by not using by using the up arrow. I inadvertently overwrote one of my malwares, so I had to create the first shell-bind TCP payloaded malware, and then I'm creating another one with a different port with the correct file name. So now when I do an ls-al, I've got 3 different files. Not all of them. Oops, I mistyped something. Yeah, thank you. That's exactly what it is. It's not XC, it's EX86. Brilliant. Thank you. Not EX, X86. Yeah, there's a benefit in typing rather than just copying and pasting. Thank you for that, whoever that was. And to answer Iman Shu's question, I believe that was Iman Shu. I still have a problem. Okay. Doesn't really matter. Yeah, yeah, yeah. Not the last two. We're going to talk about those in a second. Dash E, not F. I'm sure someone told me that. It's trying to create an encoded file. Maybe it worked. We'll have to see. Okay. Are there any questions? Were you more or less able to get those commands to work? I do not expect in your careers going forward that you will be creating a lot of viruses. I just want you to be aware of the process. If you still haven't gotten your VM working, power off and restart your VM inside of your management tool. Which is what I'm having to do here. Damn it. All right. So, is everybody at this point where you've got your 4 viruses created? In theory, they are viruses. We don't know for sure just yet. But is everybody at this point? Please note, perfect. Please note that there are some very similar sizes. When we take a look at some of these payloads, they create files that are about the same size, actually exactly the same size. It probably has something to do with having basic libraries that are necessary in Windows to do certain things. The exact reason for that is kind of out of scope for this class, but there are certain things that you need in Windows to actually execute things in Windows, and they are some libraries that are always required. And I always thought that those 3 were the exact same size for that. When we take a look at the encoded one, encoding does something to it. It kind of changes the overall structure of the file, making it a little bit more difficult to take a look at. And while we are going to look quite a bit initially at unencoded software in this class, in this course, It is very rare in the wild that you will come across unencoded executables. It's a standard technique. They will use encoding, and frankly, they will use encoding and encryption in their malware, where the executable is actually encrypted, and you can't take a look at it until you unencrypt it. Your obvious question should be at this point, well, how does it get executed if it's encrypted? Part of the unencryption process is part of the runtime environment, where the executable, as part of the execution, has the key necessary in the code to unencrypt the rest of the code. And then it will then, maybe unencode it and then execute the code at that point. It makes analyzing it a little bit more difficult, but hopefully we'll have time and I'll show you how to run through the steps necessary to decrypt and unencode your executable so you can actually understand what's going on with the payloads inside of these bits of software. Any questions on that? Some other examples? Any questions? Sorry, I don't have the sorry, I have the wrong thing visible right now. If somebody had a question, I may have missed it. Did anybody have a question? Yeah. Okay. Yours is not 355 bytes like mine is? Okay. Okay, so I've probably typed something wrong then. So don't worry about it. That's just something I wanted to show you guys is some of the different payload options. Imanshu, I'm guessing yours worked. Is that what I'm seeing by your GIF? All right. So awesome. Don't worry about the encoding because that's, I shouldn't say this, especially seeing this is being recorded and someone else is recording, and I just wanted to show you that there are some options with the payloads. Really what we're going to focus on going forward is the first one that we created. I'm not even going to focus a lot on the UPX compressed executables. I just want you to show you that there are ways of creating, and I wanted you to think going forward that there are actually encoded files. Did anybody else have a 355 byte encoded executable, or was everybody's 74K? Everybody had 74K? Okay, then I have a typo in mine, and I'm fine with that because that's not the deliverable for this course. And that's really why I keep messing it up, because I don't care and I want to move on to something else, which is the wrong answer for a teacher to have for their own content. I understand that, but I don't care. I want to move on. The next thing I wanted to talk about was the compactors that these tools, UPX, and these are used for converting your executables into something a little bit smaller. That's what they're originally for, but we see them used in the malware world because it makes it a little bit more difficult for you to understand what's going on. An interesting thing has happened, however. Lazy, let's call them hackers. They're not hackers, but lazy black hat type malicious actors have gotten lazy. They don't understand what's going on with these tools. They'll watch a YouTube video, maybe even like this, and they'll say, oh, I need to do this, and they'll just run that UPX command, as you see on slide 6, correction 5 of the handout. And that's because that's what I'm supposed to do without really understanding what's going on. At the end of the day, UPX is one of the more common packers that are used for packing your executable code. And it's become pretty easy to unpack and work with the resulting code. So if you're really under attack, chances are it isn't going to be code that's been packed with these kinds of utilities. All right. If you're really under attack, chances are it's not some payload generated from MSF Venom. It is very unlikely that those are the kinds of things that you're going to be under attack from. Because if somebody tries to attack you with these utilities, chances are your edge devices are going to detect them and block them before they get onto your corporate networks. Of course they are, because this is very introductory stuff, as we've seen in the past. Any questions on that? All right, so let's take a look at some of these packing utilities. The utility is called UPX, and we're going to bind, let's say, add user. Let's bind shell first, because we'll do it in the order that we have. Now, how did I do that? You should have a terminal that should work like this. Double click with the mouse and press the middle button, and it should copy and paste. I use the middle button on my mouse. I've shown you this before. You need to specify an output, and we're going to call this malware bind shell underscore packed.exe. Really? Do you have UPX in your environment? Do you guys have UPX in your environment? Yes or no? Yeah, same for me. Okay. I thought I tested this before I used the basic setup. Obviously, UPX is not in the basic tool set with Kali. I checked it in the medium one. I didn't check it in the beginner, the small set. Okay, this is on me. I apologize. So, this is what I want you to type in then. And you're just going to have to trust me because I don't have it here. I want you to type in sudo apt install upx. And it should let you install the Upx compactor. If you have not done so, please go ahead and install sudo apt install upx. It should work. Mine isn't working because I've got a slightly older version of Kali here. Please go ahead and try that. Is that working for you? Sudo apt install upx. Perfect. I would be surprised if it didn't because the UPX is pretty common utility. I've never had to do this before, but I'm not surprised that it worked. Once it's been installed, does the command then work? Perfect. Good. And that's what I want. That's exactly what I want, so that's good. So once you've done that, go ahead and compact the add user executable as well. All right. Just in case you were wondering what all that was on my display, I had set this unit up to do some tests, and I didn't properly set up the network. So what you saw me do was I didn't check my network settings because I could tell which of the two networks was working by the fact that I couldn't connect to the internet. And I'm sorry, I should have explained that because I know you are young and have curious minds, and I need to explain what I'm doing so that it makes sense to you so you can apply it in the future. I knew that my NAT adapter wasn't working. So I went in and I attached a new network connection to that NAT adapter, verified my IP settings, saw that NAT was now working so that I could load a web page, and then I went back and installed the necessary software, which allowed me to run the UPX command. That's what that was. Okay? And UPX malware add user.exe. The output is going to be malware add user packed.exe. And it should be pretty quick. So the upshot of all of this is that add user becomes something less when you pack it. Same with bind shell, it becomes something less when you pack it. Please note that these payloads are very small, sitting inside of these overall executables. And that's typical of these things. When we start taking a look at some of the malware in the future, we're going to see that it's very little code, actually, and it's going to be a little daunting at the time, where we're actually going to have to step through an executable, block code by block code by block code, analyzing what's going on, and you're going to see that the little bits that actually do the nefarious code are often very small. One of the ones we're going to be look at, I can't remember what it's called, but it's just going to dump all the processes. Why? So it can find vulnerabilities. Are there any processes that I can exploit at this point? These payloads tend to be very small in nature relative to the overall thing that's going on. They tend to be actually pretty compact themselves, and the better ones are going to be well optimized so that they don't take up a lot of room, and they're more difficult to detect by design. Any questions on that? Does that make sense? Did everybody get that? I'm going to try and connect again. If it doesn't, I am going to... I'm going to install Remnux here. I'm going to import Remnux. That's what I'm going to do. I'm actually going to import it right now, just in case. Just in case. We will let that run. I'm still going to try and do this in my proper environment here, because if I expect you to have it, then if I can't get Remnux working, there's no point in getting this display here. So let's see if I can start Remnux first. Okay, while it is firing up, let's talk about the next bit of our lecture here. We need to have a method of moving our malware, if you will, from one place to another. As we saw last semester when we were taking a look at moving payloads around, we had a couple of different options. These tools that we use, and I'm talking specifically about Remnux right now, Remnux and Cowley, they have a lot of tools that are available to us. They can allow us to start up and turn down secure shell server sessions, which allow us to do a secure FTP or secure shell connection. Sorry, secure FTP or secure copy connection to our machines. And we can do that, and that's fine, and it'll work. But as I've said on slide 6 of the handout, one of the easier ways, and one we saw last semester, was to use the Python module simple HTTP server. We would launch that inside of a directory, and then that directory became the document root for that temporary Python-driven website. Do you recall this from last semester, where we used the Python-M simple HTTP server? Does that sound familiar to you guys? Yes or no? Yes, sounds familiar? Okay, good. It's funny how I do that, right? It's funny how I make all of these things related. because they are all related. And I'm sorry, Manchu, you lost your connection again. I'm sorry about that, sir. If you want, you got it again. You're actually doing better than me, I think. I'm really struggling, which is just, I appreciate the irony of me struggling while I'm trying to get you guys to do the work. Um, Frickin' Microsoft. So as I said, I'm recording this. You can try it again at a later date. And to be honest, that's it for me for this week. What we're going to do in the next 20 minutes or so, that's it for me. You're going to have the rest of the week to develop your awesome. I got Remnux working. Okay, here's section 2. Let's see if I can get Kali working as well. All right. So we're going to let that run through. And while that is still trying to start up, I am going to carry on with my conversation. We need to have a way of moving our files between these virtual machines. I don't care how you do it. Okay? Going forward in your careers, that's entirely up to you. There is value in using secure shell connections, but you have to understand exactly what it is you're doing. You must, and I know I've said this many times, and you're probably going to want to throw something at me because I'm saying this yet again. You must understand your environment. And that applies to this environment as well. You must be able to visualize the different virtual machines that we have running and their relationship to each other. In today's class, we're going to create a connection between Kali Linux and Remnux. And then for the next little while, we're going to work exclusively inside of Remnux, so we don't have to worry about relationships. Everything's going to be self-contained in Remnux. But then in the future classes, when we get into dynamic analysis inside of payloads that we detonate inside of Windows, we again are going to have to create a central server and then talk to it. Consequently, going forward, I want you to start thinking of Remnux. Huzzah! Woohoo! All right. What the hell is my password? Password. Yep, awesome. All right, perfect. It's exactly where I want to be. Okay, so I want you to conceptualize this going forward. Remnux is going to be a bit of client software that we use for analysis. Remnux is also going to be, by and large, the server that we do. So we upload stuff to. Okay, and I know, and I appreciate that I'm going to break that model right now, but I still want you to think of Remnux as the main server that everything needs to get onto for analysis, or that is going to run a lot of the analysis tools that we are going to use. Okay, when we set up our third virtual machine, we're going to set up an instance of Windows, and we're going to install a stack of software called Flare VM. This stack of software is going to give us a lot of the tools that we can do dynamic analysis on malware. And again, it's going to be relatively basic. It's going to show you how to use these tools so that if you get a job in the future, you can very quickly get up to speed with the tools that these companies use. I'm going to cover concepts more than complexities. That's what I wanted to say. However, for some of these things, we need to talk to a machine. We need to talk to a server. So a lot of this stuff is going to be based on, oh no, it's going to crash. It's going to disconnect me. Look at this. It's going to disconnect me. Ah, you mother! Damn it! Ah! All right, well, adapt and move on. That's what you have to do. We're IT, we adapt and we move on. I've got Remnux here. I'm quickly going to modify the system so that I can get it up and running. I'm going to give it another 8 gig. I'm going to give it 2 cores. The display I'm going to up to 128. I do not need to worry about storage. I do, however, need to add a separate adapter to my host-only network, my primary host-only network with promiscuous mode to allow all. I'm going to start that VM. I'm going to quickly enable it on this network. If you've lost your connection, I am truly sorry. I really and truly am. All right. If you still have Kali, correction. Yeah, you don't need your browser in Kali. If you still have Kali up and running, that's awesome. That's great. If not, please follow along and try again later, and I apologize. I'm going to make this better for you. You have a lot of time to work on this stuff. It bothered me because I had it. I had all the pieces ready to go, and then it lost it. Microsoft. Breaking hearts since, I don't know, 1970 something. Look at that. And that's how Remnux should work. There it is. Okay. So we have Remnux running, ideally, and we've got Kali running. We have, as I've just done with my ls command, created some malware that we want to take a look at and see if we can understand what's going on. I'm going to streamline this process. I'm going to wrap this video up in the next 10 minutes or so. The challenge is on. Let's see who can come up with the best GIFs. I love it. I love it, guys. You're engaged. I love it. Keep the GIFs coming, please. They're perfect. Okay. So, everybody can still see my desktop, I hope. Yes? No? Yep. Okay, perfect. So, as I was saying in my lecture notes, one of the easiest ways to distribute the malware from one machine to another is to simply use the simple HTTP server. You can specify a custom port if you want. We're just going to use the default port, which is 8000. So we're going to do Python -m simple and H. Tab is your friend, by the way. All right. It will find the module for you if you start typing it. Okay. And the beauty of it is that it will tell us the port it is using. So if there was any doubt as to what the default port was, the echo that it returns when it starts up its process is displayed to us. So by typing in Python -m simple HTTP server without specifying a port, we know what the port is. Your question may be, why not just use port 80? And the answer is because you already may have Apache running on port 80, for example, and you may want to use a different port for this activity. All right? So, inside of Kali, I have created the malware I wish to analyze, and inside of Kali, I have created a website inside the directory. All right? I am in my add user malware directory, and I have started my simple web server. I can now go into Remnux and download that malware. And as I said, most everything we're going to do in Remnux is going to use a terminal. The one exception was going to be a browser. As I told you, oh, and I need one more bit of information. As I told you, we are going to use the browser from time to time to do some research, and we're also going to need to do it to download samples as well. Not only from Kali, but I have a server in the college's infrastructure that you'll be downloading malware from. Doesn't matter. I need to go back and I need to understand the IP address that I have here. If you take a look at this second tab, I know what my IP address is, and it's right here. 192.168.56.194. This is the IP address of my Kali that I ran my web server on. That means I go over to Remnux, I go to that IP address, and the appropriate, I guess I didn't have my numlock on, sorry. That's better. And the IP address, sorry, correction, the port that was specified as well. So my IP address should be 192.168.56.194, port 8000, and it will give me a directory listing. And then I can simply download those files. Right-click, save link as, and then we can save them to a specific place in our file system. What did I say earlier about file management? Anybody? Nicely, Manchu. Sorry, what did I say about file management, ladies and gentlemen? Not all at once, it's overwhelming. Separate directories for workflow. Remember? So I want to put this in the right directory. So I need to create a directory. So what I'm going to do, I'm going to go to my home. I don't have a directory. That's okay. There is a button here to create a folder, and I'm going to call that folder add user, because that's what we're going to focus our analysis on. We're going to put our malware add user exe to our add user folder. I don't care how you create the folder. You can do it through the terminal. I want you to organize your work. I don't want to see this semester everybody dumping all of their analysis in one directory. It becomes problematic for me to grade and for you to do the work. Create separate directories for your work, ladies and gentlemen, please. I have created a directory for add user, and I'm going to download my file to that. Perfect. And I can do that for each one. Right click, save link as. I am in my add user directory. I can save the packed one. I can save bind shell. Perfect. All right, not just clicking on it, but right-clicking and save link as. It allows you to better organize, and it's going to be very handy when you're downloading malware to Windows and it only has a couple of directories for exceptions. Okay? We can save them all, but frankly, we're only going to really look at one today because I really want to move this on and get into reporting. Okay? So I have downloaded my malware to Remnux. There is a directory called add user, and my malware is in there. Okay? Let's take a look at the add user executable. Okay, I'm minimizing my window just a little bit. If you take a look at, we've passed that. We've done that. We've done that. Oh, let's take a look at this. Let's see if this one works. Didn't give it to me. All right. Clam scan is what I was looking for. Yeah, it didn't upgrade my things. Clam scan is in place, but why won't it let me do my sig tool? It's not 1. No, it's L. Okay, so Clam scan isn't working right now. How do I update the virus definition for Clam scan? Okay, I'll take this away. I'll find out how we can update the signature for Clam scan. So leave that with me and we'll take a look at it. We can also, as I mentioned, and I don't want to get into VirusTotal right now, but another thing we can do, as I've mentioned here, is we can upload our viruses to VirusTotal. For that to work, you really need to ideally have an account on VirusTotal. So we're going to talk about that another day when we take a look at hashes for our viruses. But what I want you to do now is a couple of things. First off, as I mentioned on slide 7, if we take a look at edit and preferences, Our um, scrolling 10,000. Perfect. We don't have to worry about that, but sometimes we need to adjust that. In earlier versions of Remnux, this was set at something like 500 or 200 or 100 lines or something like that, and we ended up losing information. Setting this up to 10,000, that's pretty good. The scroll back lines, that's what we want. You could even make that 100,000 if you want. It doesn't really matter. It just uses up a little bit more memory. When you've only got 4 gig of RAM assigned to your VM, that might be an issue. We've got 8 gig assigned to this. 100,000 lines of scroll back is okay. You really don't want to be scrolling back more than 10,000 lines though. Okay? Because it gets lost in the noise. For any of you that have had to work in a network operation or security operations center, just staring at data scrolling by after a while becomes less than successful. Okay? So our environment is ready. We should be able to scroll back as much as we want without losing any data. We've also got our network set up and we have downloaded our files. All right? Finally, we can do something like Hex Dump. Yes? Was there a question? When we do Hex Dump, we lose a bunch of information. It just shows us the hex data of our executable, which is interesting. It might be helpful, but I don't know about you. I cannot read raw hex information. So we need to modify, and by the way, I'm on slide 12 of the handout. If we're going to use Hex Dump, maybe add some characters that will make it a little bit more clear to us. So again, what was the command I used? Was hex dump -uppercase C. It still does the hex dump, but includes some ASCII characters, making it a little easier for us to read and understand. Okay? So again, what was the command I typed in? I'm on the bottom of slide 12 of the handout, but this is the command here. Hex dump -uppercase C malware _add user.exe. And that allows us to do a hex dump of the uncompacted, unpacked, uncompressed, and unencoded executable. This is a simple executable that's ready to execute without any of the tricks that hackers use to hide their payloads. Okay? You rarely see malware looking like this. You rarely see something like this. Okay? Has everybody entered that command and generated an output that looks like this? Like this? And rather than saying a whole bunch of yeses, has anybody not been able to dump out the contents of their malware Okay. So, I should stop asking. I'm going to let you guys take this offline. Okay. But what I wanted you to see is that as you go through, and you're going to see this more and more, there's a lot of similar blocks of code in Windows executables. I don't expect you to recognize this now, but you'll see time and time again, this program will not work in MS-DOS. A whole bunch of stuff like that. You will see a whole bunch of warning messages that often appears. What you're looking for is the exception. And I realize that this is a bit of the, cart before the horse, the chicken and the egg analogy. How do you know what to look for until you start looking at a lot of different code like this? Okay. As you scroll through, however, you will eventually come to something that looks suspicious. What is suspicious? All I can tell you is what is suspicious is what you haven't seen before. Okay? And what we're looking for is something weird. And what weird is in this case, the add user statement. Okay? I may have missed it. maybe not. Let's see. So you just scroll through looking for the code, seeing if anything unusual jumps out at you. Is this as exciting for you as it is for me? Thank you, guys. At least we're all having fun. Or I am. I don't know if you're having fun, but I'm having a ball. So thank you for that. All right. And this is one of the aspects. And honestly, this is one of the least reliable ways of analyzing. I show you it because when I learned how to do analysis of malware, this is how I was first taught how to start looking at these things as well. I was shown how to create a bit of virus, not compact it, not encrypt it, and then just take a look at it and see if I could find something suspicious. That's how I learned, so that's how you're learning. Must be close to the top now. Yeah, that's what 78K does. Or 73K. 73, 78K. There's a lot of stuff that goes into Windows executables that's just always there. And that's what we're seeing. A lot of empty space as well, which is what gets compacted at some point. There are some cheats, but I'm not going to use those because they're cheats. Anytime you see a string like command.exe, worry. Okay? When you see something like command.exe, that's when you start to have some problems. Right here, we've got a block of code which is actually generating something. It's iterating through some kind of list, and then it is doing an add user command with username and password parameters, and then adding them to the group. Okay? Frankly, it looks like it's adding it to the same group that the user is a member of. So whoever is or whoever, whatever group that user can add. And that's what we're looking for, is something unusual in there. Now, I knew what I was looking for. I was looking for either the add user statement, net user statement, all right? Or the command.exe is really what I was looking for, okay? Those are the things that you look for that jump out at you when you're trying to analyze your code as being somewhat problematic. How long did it take me to scroll back and find that, right? If you take a look at my scroll bar here along the side, I'm not even halfway up. And there wasn't a lot of stuff. Well, actually, there was a lot of stuff. So maybe I'm close to the top after all. I can't recall off the top of my head, and frankly, it doesn't matter. Okay? This is one of the things that you do. You look for usual code. And in this case, it's the command cmd.exe. That tells me that there's something wonky going on with this. It is rare that you will use a tool like Hex Dump for this. You can, but there are better tools to use. For example, if you take a look at the next slide, it talks about the results of the Hex Dump command, and that is slide 13. If you take a look at slide, what is that, 14 or 15? Slide 15 shows you the output of vbin_diff, which is a little easier to read and is a little bit better for this kind of analysis. And that's what I'd like you to consider using. Rather than using Hex Dump, we're going to use vbin_diff, which I verified was in Remnux still. And again, we're going to look at malware adduser.exe. Tab is your friend, and it opens it up in something like this. And it allows us to go through and search for our code. And that's what I'm going to get you to do. This time, however, it starts at the top, and it should be a little faster at finding our payload. Okay, and I'm just using the cursor keys, the up and down cursor keys on my keyboard to find my payload. Don't get too trigger happy with this. You might miss something. Oh, what do we have here? Oh, look at that. We've got a block of code that looks very, very suspicious. It looks like the mouse works as well, which is interesting. So, if I am analyzing this block of, if I'm analyzing this executable and I am, I don't know, writing a report, I might want to try and highlight this block of code and then include that in the report. Okay? As we can see on page 15 of the handout. All right? So what does this mean? It shows us that there is something that is going to be run when this code is run. It is going to try and add a user to the system based on the credentials that we defined when we set up this malware in Kali Linux. All right? Final slide of the handout, slide 17, talks about detonation. We're going to come back to this slide in the future. In the past, I had users detonate this inside of Windows, and I kind of regret that. There was nothing wrong with it. There was no problems, but I've always said you need to be careful with this stuff, and then I turn around and tell everybody to be blasé about something, a malware that we created in a hacker's tool set like Kali, and we detonated in our Windows environment. No. Once we have our Windows payload environment set up, we will come back and we will detonate the add user malware and see if it actually does something to our environment. So we're going to hold off on slide 17 of this activity for a couple of weeks. Okay? So, what do I want you to do? Well, let's take a look again at the learn shell. Nope, that's not it. Where did I have learn running? Yes, learn. Here we go. Okay. So, I have the PowerPoint presentation that we used today. I also have a template, and this is what I want you to work on the rest of the week. And I'm going to do something horrible. I'm not going to give you any direction on this. I said this before. You saw this last semester with your reporting, and I'm going to do it again. Okay? You have to figure this out. You have to figure out what these things mean. You have to work your way through the chaos. And I'm doing this because it's very difficult to incorporate chaos in this class. Now, yeah, I've lost my VM, so that's fine. I'm not going to really worry about that. If you still have your VM running, make sure that you've powered it off. If you're not using it, you should power it on and use it, however. When I take a look at mine, it's still running and I'm not connected, so I should power it off. Okay? I want you to start writing a report. If you don't know what these things mean, I don't expect you to fill it in, all right? We have done no memory analysis. We haven't talked about doing some open source research. If you want, you can upload these things to certain websites. We have not talked about pulling hashes, all right? We have not talked about running these things through websites such as VirusTotal, which is one of the things we're going to start looking at next week. So when it says VirusTotal, search engines, those kinds of things, we haven't done that yet. You can leave that blank. fill in as much as you can, get this analysis done, include some screen caps, either as an appendix at the end, I don't care. Okay? I want you to generate a report based on the analysis that we've done where you can actually identify the block of code that you find suspect. Also, and I'm going to do this right now, I'm going to create a folder because frustratingly last semester people were submitting files that I found to be problematic. All right, so I'm going to create a new folder. The folder is going to be called Add User Analysis. Which I believe I have done. I believe I made this into a competency. I really hope that I did. I think I did. I think add user was, yeah, the report on the add user. Okay, so I want you to, when you are ready, upload your add user analysis to this folder, and then we'll take a look at it as we do your competency. Once everybody has submitted their analysis, just so we're all on the same page, I'm going to compare your submissions and make sure that nobody has broken the academic integrity rules for here at the college. Submit your own work. Collaborate as much as you want. I don't care. But submit your own work. Okay? Any questions? So, what am I looking for? I'm looking for you to do an analysis where you can take a look at one or both of these. If it's only one, I really want to see the vbin diff result, the blue result. If I only see one, I want to see this one. I don't think the Hex Dump is as effective a tool, and it basically gives me the exact same information. You can include both if you want to, but I'm really looking for the vbin diff dump. I'm really looking for this. Once you have captured that information, include it in this report. Include as much information as you can. I understand it's going to be hard for you to understand what's going on. That's done on purpose, just like it was last semester. Submit the report, and then we can do the competency. Okay? You have the rest of this week to work on it. I'm going to stop recording now. Are there any questions?